Air Transat Flight 236 dramatic incident, a fateful departure and unseen threat. On the cool evening of August 23, 2001, an Airbus A330, nicknamed Jager, taxied from Toronto Pearson International Airport with 293 passengers and 13 crew members aboard. The flight was routine, bound for Lisbon. The aircraft carried a little extra fuel as mandated by regulations. Yet deep within the sleek fuselage and complex wiring of modern aviation systems, fate was already laying its trap. Unbeknownst to the crew, during routine maintenance just days earlier, a critical error had been made. In a bid to replace a worn engine, technicians had installed a hydraulic pump component using a part taken from an older engine model. This piece, though seemingly acceptable at first glance, did not provide the necessary clearance between its accompanying hydraulic line and the adjacent fuel line. For hours, as the aircraft soared over the Atlantic, the subtle rubbing of these two lines, nearly imperceptible in normal flight, began to erode the fuel line's integrity. The slow unraveling of normalcy at first, the flight progressed as scheduled. Around 4:38 Universal Time Coordinated, while cruising high above the vast, dark ocean, the aircraft began to lose fuel at an unusual rate. The leak had begun silently in the fuel line feeding engine number 2. Initially, minor irregularities in engine oil temperature and pressure were dismissed as sensor glitches. Captain Robert Piché, an experienced pilot with a glider's instinct for managing the powerless flight, and First Officer Dirk de Jager trusted their instruments until the numbers started to tell a different story. By 5:33 Universal Time Coordinated, an advisory appeared on the cockpit's electronic monitoring system, a fuel imbalance warning. The reading indicated that one wing's fuel reserves were depleting much faster than the other. Unaware that a fuel leak was the culprit, the crew instinctively attempted to balance the tanks. They activated the crossfeed valve, transferring fuel from the left wing to the right engine. Ironically, this well-meaning action only hastened the disaster by feeding the leak directly. A descent into the unknown. With every minute, the aircraft's fuel dwindled further. At 6:13 Universal Time Coordinated, engine number 2 finally flamed out as the fuel starvation took its toll. The situation was grave, yet the crew pressed on, confident in their training and the aircraft's design. They began a controlled descent, an approach that would soon turn into one of the most extraordinary feats of airmanship in modern history. Then, at 6:26 Universal Time Coordinated, with about 65 nautical miles separating them from Lajes Airport on Terceira Island in the Azores, engine number 1 also succumbed to fuel exhaustion. The Airbus had now become a giant glider, a massive, powerless plane coasting over the Atlantic, its sophisticated systems reduced to emergency backups. The pilots quickly switched to the emergency ram air turbine, RAT, which deployed automatically to provide limited electrical and hydraulic power, essential for keeping critical flight instruments and controls functional. The miraculous glide and landing with nothing but their skill, intuition, and a deep understanding of aerodynamics. Captain Piché took command of the powerless aircraft. He executed precise S-turns and even a full 360 degrees maneuver, designed to shed excess altitude without sacrificing control. The aircraft, which had been engineered to rely on engine thrust, was now entirely at the mercy of gravity and the aerodynamic forces acting on its massive wings. The gliding flight lasted nearly 21 minutes and covered about 120 kilometers, 65 nautical miles. Throughout this nerve-wracking period, every decision was a delicate balancing act between speed, altitude, and distance. The cockpit was a picture of calm concentration amid an unfolding crisis. Though the instruments now offered only fragmented data and the usual engine sounds were absent, the pilots managed to keep the aircraft aligned with a makeshift approach to Lajes Airport. As the runway grew closer, the tension in the cabin was palpable. The descent was steep and the landing approach fast, compounded by the fact that, without engine power, vital systems like the anti-skid brakes were compromised. The aircraft touched down hard, its main landing gear absorbing the impact, and then bounced once before settling firmly on the runway. Locked brakes and deflated tires testify to the severity of the landing, yet miraculously, the aircraft came to a safe stop. In the ensuing evacuation, only 18 minor injuries were reported. Every soul on board survived. Aftermath and lasting legacy. In the days following the incident, investigators from Portuguese, Canadian, and French aviation authorities pieced together the chain of events. They discovered that the tragic fuel leak was not a random failure but the result of a maintenance error, a mismatch between a hydraulic component and its corresponding fuel line. The error had gone unnoticed until it was too late, and the pilot's decision to correct a fuel imbalance by crossfeeding inadvertently exacerbated the fuel loss. Captain Piché and First Officer Jager were hailed as heroes for their exceptional airmanship. Their ability to glide a fully laden, powerless aircraft safely to an airport was unprecedented in modern commercial aviation. The incident led to significant changes in maintenance protocols and pilot training, ensuring that future crews would be better prepared to recognize and manage such rare but critical situations. Today, the story of Air Transat Flight 236 serves as a powerful reminder of the razor-thin line between routine operations and crisis in aviation, and of the extraordinary skill and calm under pressure that can save lives when technology and human error collide. A critical maintenance error was at the root of the unfolding crisis. During an engine replacement a few days before the flight, maintenance personnel installed a hydraulic component using parts from an older engine model. This substitute component did not meet the precise clearance requirements. Specifically, it left insufficient space between the hydraulic line and the adjacent fuel line. Over time, the slight but constant friction between these two lines, caused by vibrations and the normal stresses of flight, wore away the fuel line's outer layer, eventually causing a small crack. This fuel leak began silently over the Atlantic. For several hours, the aircraft's fuel quantity diminished at a faster than expected rate, but the leak went undetected. The cockpit instruments did not immediately signal a direct fuel leak. Instead, they displayed subtle indications such as an unanticipated drop in fuel onboard figures and an imbalance between the fuel loads in the left and right tanks. At around 5:33 Universal Time Coordinated, the flight crew received a fuel imbalance advisory on their electronic centralized aircraft monitoring (ECAM) system. Believing that the issue was a routine imbalance, the crew activated the standard corrective procedure. This procedure involved opening the crossfeed valve, which transfers fuel from one wing tank to the other to equalize the load. Unbeknownst to them, this action inadvertently directed fuel from the left wing into the right wing, the very side suffering from the leak. As a consequence, instead of mitigating the problem, their actions accelerated the loss of fuel. In essence, the maintenance error set in motion a chain reaction. The improperly installed component led to a fuel leak that remained hidden by conventional monitoring methods. Then, standard operating procedures, while generally effective, failed in this rare scenario, as the corrective crossfeed procedure fed additional fuel into the leaking line.